In this lecture, we'll complete our algorithm analysis for the operations, the methods, in our queue class. We'll start with the enqueue method that adds an item to the back of the queue. So pause the video if you need to at this moment to look at the code here, and then go do an in-video quiz about the algorithmic complexity of the enqueue operation. And the answer is, if we don't have to grow the list, it's order 1, and if we do have to grow the list, it's order n. So you can either say it's order 1 amortized, or you can say it's order n, because that is the worst case. For dequeue, we know we can't dequeue from an empty queue, so we check that first, and then we access the front of the list and then remove the front of the list and return the item. So again, pause the video if you need to think about this, and then do an in-video quiz about the algorithmic complexity. Well, it turns out that this is constant time, and this is constant time, and this is constant time, and darn, this one is not. Remove at is going to be order n, because we're removing the very front of the list, and that means that all the rest of the items in the list get shifted down one. So dequeue is actually an order n operation. Now you might think that that just means we made a poor decision, that the front of the list will be the front of the queue, and that we should have made the front of the list the back of the queue, just like we did when we were using the back of the list as the top of the stack. The problem with that approach with the queue, because we deal with both ends, adding at one end and removing from the other, is if we did that, then enqueuing would no longer be doing this. We'd actually have to figure out a way to add to the front of the list, which would mean that everything in the list would have to get shifted up. So we would be making it so enqueue is an order n operation, so that dequeue would be an order 1 operation. Because the list class doesn't give us a way to add at a particular location, that's harder work than it's worth. So we might as well just leave it the way we have it and just pay the order n cost when we dequeue an item from the front of the queue. Finally, peeking at the front item on the queue, you should already know this, but go do an in-video quiz about the complexity. And the answer is order 1, because order 1, and order 1 constant time to access a particular element of the list. To recap, in this lecture we got more practice doing algorithm analysis, and we also learned that peeking at a queue is always constant time, an order 1 operation, but one of the dequeue or enqueue operations is going to have to be order n, because we interact with both the back of the queue to enqueue something and the front of the queue to dequeue something.